Okay, this lesson is on forces. And if you do notice this picture here, it says, may the M times A be with you. Do you know what M times A means? You can probably guess. That is the formula to find force. Okay, so what is a force? A force is simply a push or a pull. And the Newton is the unit that's used to express force. So we've talked about how if we want to know what kind of units measure distance, we can say inches, yards, miles. If we want to know what type of unit measures mass, you can say grams. And the unit used to express force is a Newton. And this says when you pull a stuck door, you are applying more force to the door. Anytime that you push something or pull something, or something is pushed or pulled, it is a force. Miss Norval's Christmas list. I have no idea how that got in there. Next slide. All right, forces act on objects. A force is always exerted by an object and always acts on another object. So what this pretty much means is that at all times something has a force applied to it. The net force is the result from combining all of the force exerted on an object. So for example, let's look at this piano. You have a girl pushing it with a force of 25 newtons to the right, and you also have a gentleman that is pulling a force of 20 newtons. So to find the net force, if it is going in the same direction, you would add. So altogether here you see that the net force is 45 newtons to the right. If it was opposite directions, you would subtract. We're going to get into that a little bit later. All right, so forces come in pairs, and they also have a magnitude and a direction. So what I mean by that is that they have the force, the newtons. So the magnitude in this example would be 5 newtons. And then they also have a direction. And in this example, it would be north or up. So forces have a magnitude and a direction. All right, so there are balanced and there are unbalanced forces. And these forces occur in pairs. And those pairs can either be balanced or unbalanced. So let's look at that. Balanced forces. This is pretty much when an object is not moving. So this says a stationary object will not move while the forces acted on it are balanced. So if you look in the example here, you have a force pushing the car to the right, and you have a force pushing the car to the left. But the car is going to stay still because the forces on it are balanced, meaning these fingers or these people are pushing that car with the same force, and because of that, it's not moving. Balanced forces are not going to cause a change in motion. It will remain stationary. They are equal in size. The force is equal, the same amount of newtons, and it is opposite in direction. So if you look here, for example, playing tug of war. If people are going opposite directions but pulling with the same force, nobody's going to be moving. Think about an arm wrestling match. They're both pushing inwards, but if you're pushing with the same force that is equal in size, nobody's going to be winning. Okay, the opposite happens with unbalanced forces. You're going to need to know that when it is not zero, when the net force is not zero, the forces acting upon the object are unbalanced. You can even think about an unbalanced person. If they're unbalanced, they're moving. This always causes a change in motion. So let's look at this car example again. The force that you have the person pushing the car to the right, but if there's nothing acting against it, the car is going to move to the right. There's not enough force to push it backwards or to keep it to remain stationary. There's more force going to the right. Let's look at the arm wrestling example again. What if you have one guy pushing 3 newtons to the right, but then the other guy is pushing 6 newtons to the left? Somebody's going to be winning, and it's going to be the guy that's pushing with the greater force. It is unbalanced. There is motion occurring. Same thing with tug of war. If somebody is pulling with more force, that's where the rope's going to go. All right, so let's look at some problems for net force. And after this video, you will have some practice problems to do on your own. But you're looking at the direction the forces are occurring, and if it's opposite or if it's going the same direction. So in order to find the net force, you first need to look at what forces are going which way. And in this case, we have forces going to the right, and we have forces going to the left. The forces that are going to the right are 22 newtons and 25 newtons. The forces that going to the left is 24 newtons. So altogether in the right you have 47 newtons, and altogether in the left you have 24 newtons. And as I stated earlier, if the forces are going in the same direction, you're going to add, but if they are going in opposite directions, you will subtract. So to calculate the net force here, we found out the total going right, we found out the total going left. To find the net force, we're going to subtract the opposite directions here, and we see that the total net force is 23 newtons and is going to be to the right. Remember, forces have a magnitude and a direction. So which way is this box going? It's going to the right. Let's look at another example. In this case, you have the box is being pushed down, and it may be also pulled up. So we're going to look at down, and we're going to look at up. Forces pushing down on the box are 15 newtons, and it looks like it may be pulled, however you want to look at it, 8 newtons as well, down. When looking at how much is going up, you have only 14 newtons. So altogether, the force going down is 23 newtons, and altogether, forces going up is 14. Those are opposite directions, so to find the net force, we will subtract those, and you will get 9 newtons down. That box is going down. Okay, so now click Next in Canvas and try some on your own.